Hi guys, welcome you all to my channel Explore Edu to Teach.
The next topic that we are going to learn in digital electronics is the concept of decoders. Many combination circuits like multiplexers, demultiplexers have all been uploaded on my YouTube channel in digital electronics playlist, so please do watch it from there. Last video was on encoders, so eventually this video is going to be on decoders. This is the final topic of combinational circuits. The next topic is going to be of sequential circuits, and again there are going to be series of lectures which are going to be uploaded on sequential circuits as well. So please, if you like this particular content, do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram as well. The links are given down in the description box. Instagram page has all the important information of all the short videos, formula, trick, concepts regarding all the video lectures which go live on my YouTube channel. So please do follow me over there as well. So let's begin with the topic decoders. So what is a decoder? So decoder is nothing else than the opposite of encoder. Encoder basically encodes my input into certain binary. So a decoder is a combinational circuit that has n input lines and maximum 2 raised to n output lines. So that is something very important. A encoder basically encodes my input into certain binary output. Similarly, a decoder is a combinational circuit that has n input lines and maximum of 2 raised to n output lines. So if I show you a 2:4 decoder, a 2:4 decoder, as the name suggests, is going to have two input lines A1, A0, E is nothing else the enable, and four output lines Y3, Y2, Y1, Y0. So a decoder is basically acting like a combinational circuit which is going to perform operation opposite to that of your encoder. It is basically going to transform my n input lines into 2 raised to n output lines. So as I am giving you an example, there can be 2:4 decoder, there can be 3:8 decoder, there can be 4:16 decoder, so on and so forth. We are of course going to solve certain numericals also on the same, so you'll get a better understanding. But this is the theoretical part of it. So if I have to map it onto a truth table, it can be so and so forth. The enable always has to be 1. Since it's an active high enable, it always has to be 1 for this output to be present. So the A1, A0 is given as 0, 0, 0, 1, 1, 0, 1, 1. So if it is 0 and 0, the Y0 output goes high. If it is 0 and 1, the Y1 output goes high. If it is 1 and 0, the Y2 output goes high. If it is 1 and 1, the Y3 output goes high. So I hope I am very clear with this. So you can have this equations from this. Y0, if I talk about, is given as E into A1 bar, A0 bar. The Y1 is given as E into A1 bar, A0. Y2 is given as E into A1, A0 bar, and Y3 is given as E into A1, A0. Understand this thing that a 0 is always represented as a bar, whereas a 1 is always represented as no bar. So I hope I am very clear with this. So based on this particular equation, you can always draw a logic diagram for the same, wherein Y3 is going to be Y3 is going to be E, A1, A0. So the Y3 consists of E, A1, A0. Similarly, the Y2 consists of E, A1 and A0 bar. So just the equations are converted down to logic diagrams. Now we have two numericals which we'll be solving over here. These notes are uploaded on my Google Drive link, and it has been uploaded. The links are uploaded in the description box, so you can download the links from there. As well as this short summary is uploaded on my Instagram page also, so you can check it out over there, and do not forget to follow me as well. So if I talk about, there are two questions wherein we'll be talking about designing a decoder in two different forms. One is going to be the active low, the other one is going to be the active high. So I hope I'm very clear. So let's try to understand. The question says, design a decoder for the following. The function of a, b, c is given is equal to y is equal to pi m is 0, 2, 3, 5, 7 using a 3:8 decoder. So I hope I am being very clear with what I want to say. So we have to design a decoder for the same. So understand this thing. We have a decoder given as function of a, b, c, which is equal to y is equal to pi of m 0, 2, 3, 5, 7 using a 3:8 decoder. Now if I just consider this diagram, we have a 3:8 decoder, okay, wherein the enable, the E is missing over here, it is a E bar, okay, active low, so we are putting a grounded input for that. So we have three inputs, that is A, B, C, and the outputs are Y0 to Y7, that is 8 output lines. Now since I say it's an active low, so what is going to happen is that we are going to represent it with a bubble and with a NAND gate. I hope that you are very clear with this. If you want to design a decoder with an active low kind of logic diagram, remember that it's a 3:8 decoder wherein we are going to have three input lines A, B, C, and we are going to have 8 output lines Y0 to Y7, in which your 0, 2, 3, 5, 7 are going to be 0 bar, Y2 bar, Y3 bar, Y5 bar and Y7 bar. It is going to be connected to a NAND gate. Since it's an active low, it is given as pi of m. We are going to have bubble and we are going to have a NAND gate. So this is a representation of a decoder using a active low. So the next question talks about construct a design a decoder of 3:8 wherein we are going to have active high inputs, and the question is given as function of a, b, c is equal to y is equal to summation of m 1, 3, 5. So it's a 3:8 decoder wherein we have three inputs a, b, c, and we have 8 outputs y0 to y7. So since it's active high, we have 1. Now since it's active high, remember one thing, that there is not going to be any bubble. There is not going to be any sort of bubble. It is just going to be a simple input line. There is going to be a OR gate and there is going to be a output Y. So this is very important. So as the name suggests, it's active high summation of M. There is not going to be any bubble like we have in case of NAND, active low kind of NAND gate. It's going to be Y1, Y3 and Y5. There is going to be a OR gate and there is going to be output Y. Whereas in case of NAND gate, for pi of m active low, we should have bubble and a NAND gate. In case of active high, for summation of m and OR gate, we have just 1, 3, 5. We have OR gate. We don't have any sort of bubble or a NAND gate. We have no bubble concept and we have a OR gate over here. So this is very important. In the examination, they might ask you to design a decoder based on active low and active high, and do not get confused. You should be very clear with this. So I hope that you understood the concept well. This was the last video on combinational circuit as decoders. The next video will be coming up on sequential circuits. Then there will be video on DAC and ABC, so on and so forth. So many more videos coming in the future. So please do subscribe to my YouTube channel. Share it to as many people as you can, and if you liked it, do not forget to like it as well. Comment in the comment section and also follow me on Instagram. The links are given down in the description box. Thank you so much.